Hey guys, this is Einar. I hope that you're doing great today, and welcome to this tutorial where we're going to be talking about critical t-values and how to look them up in t-tables like the one we have to the left here. So, first I'm just going to do some calculations, and then I'm going to explain exactly what it is that we have done, so we have something to work from. So we have a table here called critical values. This is where we're going to put our critical t-values, and we have columns here for varying degrees of freedom. We also have rows here for confidence level. So we have our degrees of freedom here and the confidence level here in the rows. Let's say then that we have 5 degrees of freedom. So we have a very small sample, probably 6 people, which gives us around 5 degrees of freedom. What I need to do is I need to look in the table here and find df, which stands for degrees of freedom, and I move down the rows here to 5, because for each row I get the critical t-values at various confidence levels for different degrees of freedom, and they're going to vary. So I go down to row number 5 here, and I see that we have our critical t-values here. So I look at my confidence level, I see we have 99% confidence level, and I see the column here corresponds to that. So we have 99% confidence level here, and we have our degrees of freedom row here, and they two meet here at 4.03, which is going to be our critical t-value. So I write 4.03 right there. And with that, we've actually looked up the critical t-value using a t-table like this. So what have we done here? Well, I'm going to use this little diagram here to kind of explain what's going on. To begin with, let's write in the degrees of freedom. We have 5 degrees of freedom, which probably means that we have a very small sample, probably 6 people. You know, the degrees of freedom is n minus 1. So a very small sample, which is going to affect our critical t-values because the t-distribution changes its appearance depending on the number of degrees of freedom that you have. For example, if you look in the first row here with 1 degree of freedom, extremely small sample, we can see that for a 99% confidence level, you have an extremely large t-value, 63.66. But as we move down here, the rows, as our sample size increases, we can see that the t-value decreases, which reflects the fact that the more people we have in our survey, the less uncertain we are about whatever it is we're studying. So the next thing to remember is, okay, we have the confidence level of 99%. What does that correspond to? Well, it corresponds to the shaded area in the diagram, and this can vary between different t-tables. So sometimes you'll see t-tables where the shaded area is one of the tails or both of the tails. So you really need to be careful about that. In our case, the shaded area represents the area between our critical t-values. So what we're saying here is that 99% of our probability is in between our critical t-values here under the curve. So I write down 99% there. Okay, so if I have 99% in my shaded area here, how many percent do I have in my tails? This is interesting because it says something about the uncertainty that we have in our value or our estimate or whatever it is we're studying. So I need to find the total uncertainty, and then I need to divide it by 2 because it's going to be equally distributed between these two tails here. So what I do is I write equal to 100 minus 99, which gives us the total uncertainty that we have in a distribution, and then I need to divide it by 2 because it's equally distributed between this tail and that tail. So I find that I get 0.5% uncertainty in this tail. Correspondingly, I go 100 minus 99, okay, the total uncertainty that we have, divided by 2, and which gives us 0.5% in this tail, 0.5% in that tail, and then 99% here in between our critical t-values. Where do our critical t-values end up? Well, I've put a little area for them here as well. What we have here is minus 4.03 because this distribution is symmetrical. So I know that the negative version of our critical t-value is going to be negative here because it's below 0, and the corresponding positive one is going to be the same, except it's a positive value because it's above 0 here. So with that, we filled in all the information that we actually looked up in the table, and we have it here in this diagram. If we move on then and move over through these columns, we can get the confidence levels for 95 and 90% as well. We're still staying in the same row because we have the same number of degrees of freedom. So the same row, but we're moving through the columns here. So if we go to 95% confidence level, I look at the column for 95% here, move down till I reach row number 5, and I get 2.57. So I write 2.57 right there. If we're going to fill in the values here in this diagram here, well, the number of degrees of freedom is the same, so that's going to remain 5. The percent here in the shaded area, however, is going to change because we changed our confidence level. This time the shaded area corresponds to 95%, so I write 95% there instead. That also means that the percents here out in the tails is going to change. In fact, we're going to get 100 minus 95% divided by 2 in each tail. So what I do is I write 100 minus 95, which then gives us the total uncertainty outside our interval here around 0. And then we divide it by 2 because we have it distributed equally in these two tails. So I get 2.5% in this tail, and then I go 100 minus 95 here and divide that by 2 as well, and I get 2.5 in this tail. So if just so you know, if we add them all up, we get 2.5 plus 95 plus 2.5, which then gives us 100%, which corresponds to the entire area under this curve. So there you have it. How to place your values in here. We're going to do this also for 10 degrees of freedom, just to practice. So what we're changing now is we're changing rows. So we're moving down, we're adding people to our study or whatever. We're going to decrease our uncertainty a little bit. So we go up here and we go to row number 10. And if we're going to do this for the 99% confidence level, I go down to row 10, and then the column where 99% confidence level t-values are located. And I get 3.17, so I write 3.17 there. And you'll notice now that the confidence level is the same, but because we increased our sample size, the t-value decreased, which means we have lower uncertainty in our estimate. So that's how the t-distribution works. And as I said, you know, when you reach 30, the t-distribution actually looks a lot like the normal curve. So one rule of thumb that's used very often is that you say that if you have a sample size below 30, then you use a t-distribution. If it's above 30, you use the normal distribution. This is not a set in law, it is just a rule of thumb, so bear that in mind. But that is one rule of thumb that people sometimes use. If we're going to fill in the values here in a diagram, well, I changed the degrees of freedom to 10 here because we've increased our sample size. However, the confidence level, well, it's going to be 99%, so it's the same as for our first t-value. And if you remember, that was going to be 100 minus 99 divided by 2 in each tail. So I go 100 minus 99 divided by 2 there. So I get 99% here, 0.5% there, 0.5% there. And if I add them all up, just to practice and prove this to you, 0.5 plus 99 plus 0.5, these all add up to 100. So I know that I've done it correctly at least. And I need to change the critical values here, of course, so they're going to be 3.17 here. And it's negative, so it's negative 3.17 and positive 3.17 over there in this tail. If we go then to the 95% confidence level, well, we go down to row number 10 here for 10 degrees of freedom, and the column with 95%, I get 2.23 there, so my new critical value is 2.23. It changes the confidence level, so I write 95% there, and go here and I write 100 minus 95 divided by 2, get 2.5% in this tail. Then we get 100 minus 95 divided by 2, I get 2.5% in this tail, and then the critical value is 2.23 here. And this is the negative version, so 2.23 negative and positive here, because here the critical t-value is below 0 and here it is above 0. So I'm going to leave the rest of these cells open here for you to practice, but they will be correctly filled in the answer file, so you can check your answers. Have some fun with this. I hope you enjoyed this tutorial and have a really great day. Okay, bye bye guys.